is the song about the p-value, is the probability, okay? And Brown Eyed Girl song. Y'all good? Need to sing it? We're good? Okay. So here we go, number 18. 90% confidence interval is this. Here is the key to this problem. The key to this problem, because see, once again, I am thinking about what the null in the alternative hypothesis would be. Okay, so my null is that the average is 86. So what happens is, if I see that this 86 is not in my interval, then I think when I go run a test, I'm probably going to reject that null hypothesis. So that was the key to notice, that 86 is not in the interval. So since it's not, I anticipate that when I run a test, I get a p-value small enough, and I'd reject the null. 19 was just 70% confidence, which means that's what's in the middle. So therefore, this critical value is inverse t of 1 tail. I think technically you have 2 critical values when it asks you for something like that. And number 20, I'm not going over too much. This problem here, I'm actually going to reference more in depth on the next page. So let's just hold off if you have a question on that. 21, your sample is right in the middle. Okay, 22, we've done this before. You remember that if your sample is in the rejection region for 10%, then it is definitely in this rejection region for 20%. The question, is it in the rejection region for 5%? And that answer is not necessarily. It might be down there, but it could be here. And in that case, it's not in the 5% rejection region. Okay, we've had that before. I think there's even a multiple choice one on there that you have in your hand. Whatever. All right, last idea. Here it is. Okay, this one is saying that the sample size is 15, so our degrees of freedom is 14, and the alpha is 10%. So the key to these problems is this, the tails. Since this is indicating 1 tail, then I know that this 10%, the entire 10%, is located in this upper tail. Okay? So then to find this critical value right here, this t star, I'm going to inverse t of the area below, 0.9, 14 degrees of freedom. And that's how I get my 1.35. C is almost identical, it's just this lower tail. So since this here is the lower tail and the entire 10% is in the lower tail, it's the same symmetrical critical value, but negative 1.35 because it's inverse t of that lower 10%. Okay. B and the 2 tails is where it differs. Because if you have 2 tails, then the 10% is split between those 2 tails, and you have 2 critical values. The lower one at inverse t of 1 tail, and the upper one. Okay? Now, this question was not asked, but it's an extension. How confident are you going to be for part A and part C? They're the same. And that would be what's in the middle. So see this right here? If this were a confidence question about what level of confidence do you have, part A and part C has 80% confidence because they put 10% in this 1 tail. So by symmetry, you have the other 10% in this lower tail, leaving 80% in the middle. Okay? But since on part B, the 10% is split between here and here, then that's a total of 10% between the 2 tails, giving you 90% in the middle. So that's a 90% confidence of how much you have there. Okay. Questions there? All right, then the final 24 and 25 are about this being a problem about the difference. So since this is about the difference, then I'm interested in if 0 is in the interval. And so as you can see on 24, 0 is not in the interval, so I am confident of an actual difference. Because here, if 0 is in the interval, there could be 0 difference. That's what's happening. Am I saying there is? But no. But there could be 0 difference if it's in the interval. Done. Okay, so that's all I have to say about that. Any other questions? Okay, ta-da. Yeah, Byron, what you got?